Welcome back, Analytic Geometry students. Today we're going to be talking about the hyperbola. Continuing on with our conic sections. Now, hyperbolas are formed by two cones called a double napped cone that intersect at their vertex up here at the top. And what you're going to get is two pieces. You get a slice when the intersection of the plane cuts the top cone and the bottom cone. You get two parabolic shapes. And that's called the hyperbola. Hyper meaning more than one, maybe. Hyperbola. So what you end up getting, let me share my screen with you so that you can see what I'm looking at here. What you end up getting is you end up getting two branches. And they may go left and right, and they may go up and down. Let's take a look at these two branches. You get two branches like this. Maybe this is my X, and this, well, these are going to be centered at 0, 0 in this, in chapter 5. Everything's centered at 0, 0. Continuing on with that, you're going to get two branches, and within those branches, you're still going to have a focus. It's going to be somewhere within your branch. And remember, focus always deals with the variable C. And this vertex deals with the variable A. So notice that C is going to be bigger than A this time. But let's talk about the definition of a hyperbola. This time, every single point, if you look at the distance from this focus to a point and look at this distance from here. So if you look at distance 1 and distance 2, the distance from any point on the hyperbola to the focus, and there's going to be two of them, the distance to each focus. This time when you subtract them, it doesn't matter which one, distance 1 minus distance 2, let's make it an absolute value. Subtract them and find that length. It's always some constant. That constant actually happens to be twice the length of A. Happens to be twice the length of A is that constant. But let's write that definition down. It's the set of all points. Set of all points, oh goodness, set of all points XY in a plane, set of all points in a plane, such that the difference, the difference, I'm going to say the positive difference. In other words, you're going to take the absolute value. The difference between the distances is constant. All right. So let's think about this a minute. With the ellipse, it was the sum of those distances is constant. With the hyperbola, it's the difference. You subtract the two distances and you always get a constant. So we're going to look at the two different cases that happen. Notice you have a vertex here and a vertex here, but no vertices on the other axis. That's different than with the ellipse. You have vertices and co-vertices. With the hyperbola, you just have vertices. So let's look at this first example that we have. Let's see. And let's draw it like this. So you're going to go over A and negative A. And we're going to make it B. And then we're going to go up B, even though we don't have a vertex there, and down B. And what you're going to look at is the rectangle that is formed by those 4 points. Now, after that rectangle happens, you can see that we're going to have a line that could go through there and a line that can go through there. And those lines are going to be asymptotes. Remember, asymptotes you learn kind of distinctly in your line. It's a line that your graph approaches, okay, as it gets further and further to the extremities. And so that's exactly what happens here. So you're going to have an ellipse, not ellipse, a hyperbola or branch of the hyperbola going on the right and a branch going on the left. So case one case 1 is going to be the major axis is considered to be the x-axis. That's because the vertices are on the x-axis. So case 1, the major axis is the x-axis. The equation is going to look something like this. X squared over a squared minus y squared over b squared equals 1. Do you see a difference there? With the ellipse, that's a big old plus sign. So that's where you get into, if it's an x squared minus a y squared, it's got to be a hyperbola. That's what happens. Okay, so let's see. In this case, though, c squared is equal to a squared plus b squared. So your focus is going to be somewhere out here, and your focus is going to be somewhere out here. You're going to have the foci, and the distance to there is still c. The distance to your focus from the vertex, from the origin is c. All right, so that's how A, B, and C relate. Notice there is no co-vertices. You just have the center, which is at 0, 0. You have vertices, which are at A0 and negative A0. So we'll say positive and negative A0. You have vertices. You have foci, which are at positive C and negative C0. You have asymptotes. Okay, let's look at these. So let's see, y equals mx plus b. Now, because these go through the origin, our b is going to be 0 of these two lines. I'm going to ask you to find the equation of that. All we need then is the slope. Let's see, you rise b and run a. So you write, so rise b, run a, and that's this one. But this one, you fall b, go down b and over a for this equation. So if you want to get both of them, it's positive and negative. So y equals positive and negative b divided by a x. And that will get both equations of those two lines. All right, let's see what else we have here. The length of the lattice rectum. The length of the lattice rectum, we've been finding those all week, is still going to be 2b squared over a. So the lattice rectum, remember, is the length of the segment that goes through the focus. And so we can find the length of that and the length of that. That's the lattice rectum. That's the lattice rectum, that whole segment. Now I can ask you to find the endpoints if I wanted to. In this case, we'd go over C and up half of that length. So the endpoints of the LR are going to be positive and negative C, go over C, and then up half of that length. So up or down, and that's going to be half of that will just be B squared over A. And finally, the eccentricity, which just describes the shape. It describes if this is squished hyperbola or open hyperbola. In this case, the eccentricity E is found the same way. It's C over A. But because C is bigger than A, this time that's going to be greater than 1. Your eccentricity should always be larger than 1. It can be equal to 1. Okay. Let's see. Let's look at the case 2. That's case 1. The major axis is the x-axis. Let's look at case 2. In this case, the major axis is the y-axis. So let's picture this. Okay, let's see. You can go up and down. We'll go up and down A, and those will be our vertices. And then we'll go left and right B. It doesn't matter where it is. We'll just say B is right there. Now B doesn't have, and A do not have to have the same relationship that they had in the last one, in the ellipse. A does not have to be bigger than B. Let's draw that little rectangle. so that we can draw our asymptotes in. There's one asymptote that's supposed to go through there. And another asymptote. Okay, and so this time the major axis is the y-axis. And so our branches are going to be going up and down like that. Your focus is going to be somewhere in here. Focus is somewhere in here. Remember, the focus to there is your C. Okay, that's going to be negative C, and this is going to be positive C. This is going to be A, this is going to be B, and so on. Notice no vertices, no co-vertices. Okay, this time the equation is y squared over a squared minus x squared over b squared equals 1. Notice this time it's the positive. A is not necessarily bigger than B. Okay, not true this time. It's over. If this is a positive 1, then whichever one is positive, this is the positive, that's what A is. A is under your positive term. And this, once again, C squared is equal to A squared plus B squared, where in the ellipse it was a subtraction. Okay, the center is at 0, 0. The vertices this time are 0, A and 0, negative A. So 0, positive and negative A. Let's see, we have foci at 0, C and 0, negative C. Let's see what else I have you list. What else did we list before? The asymptotes. Look at these. Okay, look at these asymptotes this time. This time we're going to, if we do y equals mx plus b, the b is still 0 because it goes through 0, 0. But this time, and I don't memorize this, I just look at the graph. We're going to rise A and run B. So positive and negative A over B this time. That's going to be different. It's going to be A over B. All right, the endpoints. Oh, length. The length of the LR is LR. Length of the lattice rectum is still 2B squared over A. So the lattice rectum goes right through there, right through there. It's the length of that is 2B squared. So endpoints, though, is going to be positive or negative B squared over A, comma, and then we go up C. So positive, negative, or down C for these points right there. Okay, so you have 4 of those. Let's see, last thing is eccentricity. Eccentricity is still the ratio of C over A, and it's still greater than 1. Okay, I think it's time to do an example. Let's try an example. These are going to say the directions are going to be sketch and discuss. And everything that I wrote down, all the attributes that I wrote down about these, you should find for each of the hyperbolas. First problem. Y squared over 16 minus x squared over 9 equals 1. Okay, that's nice. This one's positive. And so our A is going to be, that's A squared. So our A is 4, our B is 3. Okay, because it's the negative term. All right, so that's easy enough. So we got A and B. Let's see, C squared is equal to A squared plus B squared. That's going to be what, 16 plus 9. So it looks like C squared is going to be 25. So it looks like C is 5. That's easy enough. Let's start sketching this thing. I can sketch it down here. Okay, let's start discussing it too. The major axis. That's easy enough. The major axis, because the y term is first and it's positive, is the y-axis. So on the y-axis, we're going to be going up 4. And there's going to be a vertex. And down 4. There's going to be a vertex. So the center, of course, is 0, 0. Vertices are going to be 0, plus and minus 4. There are no co-vertices, okay? The foci involves the C. So the foci are going to be up here at 5. There's a focus, and there's a focus. There's a vertex, there's a vertex. Okay, the focus are going to be at 0, plus and minus 5. Let's see what else. Let's see, we got to go over 3 this way and over 3 this way. And we build our rectangle going through the vertices. Going through the vertices and those, let's see, so there is an asymptote there. And there is an asymptote there. Let's see, our major axis on the y-axis, so it looks like it's going to go like this. Notice the focus is in the middle there. Looks like it's going to go like that. Okay, we've got it sketched. That's a good sketch of it right there. The branches are up and down because they're on the y. They touch the y-axis. Okay, so let's see. Let's start with the asymptotes. So it's y equals mx plus b. We know that the b is 0, so we're going to do positive and negative. Let's see, what do we rise and what do we run to get to this point right here? We're going to rise 4 and run 3. So 4 over 3x. All right. The length of the LR, let's see, let's come over here and do some scratch work. 2b squared over a, that's going to be 2 times b squared is 9 over a, which is 4. That's 18 over 4. That reduces to what, 9 over 2? Yeah, 9 over 2. If you want to put 4.5, you can. The length of the LR is 4.5, and that's 4.5 goes through the focus. All right. All right, the endpoints, these 4 endpoints, let's look at them. Endpoints. We know they're going to involve C. The C is going to be our 5, and that's going to be plus and minus 5. And we're going to go over half of that length here and half that way. So that's going to be our X value. So it's half of that. Half of 9 over 2 would be 9 over 4. Yeah. Positive and negative 9 over 4. If you want to put positive and negative half of 4.5, 2.25, you can do that. You can write it that way. And finally, the eccentricity is C over A. Let's see, 5 over 4, which is bigger than 1. There is all of the information that I expect you to discuss when you graph a hyperbola. Okay, well, you know they're not always set up so beautifully like that. So let's try one where the equation doesn't look quite right to start with. Still the same direction, sketch and discuss. How about 36x squared minus 100y squared minus 225 equals 0. It's a sketch and discuss. Now we know it's a hyperbola because first of all, it's in the hyperbola unit, but let's see, that's an x squared minus a y squared. We know it's got to be a hyperbola because it's not a plus. If it's a plus and these are equal, then that's a circle. If these are different and that's a plus, it's an ellipse. So we're down to hyperbola because it's a minus. So we know it's hyperbola. So we're going to move that number to the other side and get 36x squared minus 100y squared. It looks like we're going to add that to the other side, be 225. Now we need to get that 1 right there. So we're going to divide everything through by 225. Okay, so this actually simplifies. Let's see, x squared. Ooh, let's see. 4 will go in there, 9. 4 will go, 4 will go in, let's see, not, no. 9 will go in there, 4. 9 will go into both of them. 9 will go in there, 4. 9 will go in there, 25. So it looks like 4 over 25. When I bring that down into the denominator, though, it's 25 over 4. Because this is x squared is multiplied by 4 over 25. If I want to divide it, I need to divide it by the reciprocal. That'll be 25 over 4. Minus, let's see, 25 will go in there, 4. 25 will go in there at 9. So it looks like 4 ninths. So I can write that as y squared divided by 9/4, because dividing by 9/4 is the same as multiplying by 4/9. So there is the equation. We just got the equation. We're supposed to sketch and discuss this thing. Okay, the major axis is going to be the x-axis, because that's positive. Has nothing to do with which one is larger like it did with the ellipse. It's which one is positive. So it's the major axis. Now that means A is going to be the square root of that, and the square root of that looks like 5/2 or 2.5. And B is going to be square root of that over square root of that. Looks like what, 3/2? So I worked some that had not quite so easy. So what is that? 2.5, and that's what, 1.5? Okay, so let's see if we can sketch this thing. I think we have enough information to sketch it. Major axis is the x-axis. 1, 2, 3. 1, 2, -3. Let's see it. 2.5 is A, and -2.5. Okay, and then at 1, 2, 1, 2, there's -2 and 2. That's 1.5 is B. 1.5 is B. We use those to draw our rectangle. Some people call it a box. Go ahead, it's a box if you want, a rectangle. We use that to draw our box, and then we can draw in our asymptotes. Asymptotes always go through the corners of the box and through 0, 0, or the vertices of the box and through 0, 0. Okay, so it looks like those are our lines. And let's see, major axis is the x-axis. So it looks like it's going to go like that. That's a pretty good sketch of it right there. Now there's a couple things we haven't found. We haven't found C yet. Remember, C squared is equal to A squared, which is 25/4, plus B squared, which is 9/4. Is that 34/4? So it looks like C is equal to the square root of 34/4. Well, that would be square root of 34 over square root of 4, which is 2. Or approximately, if you want to say about 2.9, grab your calculator and see what it is. It's about 2.9. So your focus is right there. And your focus is right there. Okay, let's do all this discussion now. If you want to go to decimals, it might be easier on this decimals. Let's see. The center is at 0, 0. Don't miss that one. Let's see. We go over here to this. That was our A. Our A is 5/2. So our vertices are plus and minus 5/2, 0. We don't have co-vertices because this is a hyperbola. So let's see. Our focus is, C. This is C. So our C is, you can write it plus or minus square root of 34/2, 0. Or you could, if you want to write it plus or minus 2.9, 0. If you want to round it to the nearest 10th, I am quite all right with that. That's quite all right. Okay, asymptotes. Y equals mx plus b. This is b is 0. So let's see, what are we rising? We're rising 3/2. Let's find the slope. We rise 3/2. We run 5/2. It looks like that's going to be 3/2 times the reciprocal 2/5. It looks like we get 3/5. Looks like we get 3/5. So let's write positive and negative 3/5x. All right, moving on. Let's see. We need the length of the LR. Length of the lattice rectum is 2b squared over a. That's going to be 2b squared. Okay, that's 9/4. 2 times 9/4 divided by a, which is 5/2. Grab a calculator and simplify that. 2 times 9 over 4. Let's see, that's going to be 2. It looks like it's going to be 9/5. All right, so the endpoints of the LR. Okay, so let's see, they're going this way. So you go over C. So you go plus, if you want to write plus and minus 2.9, you can. Plus and minus 2.9 or square root of 34 over 2. Comma, and then up half of that length. Up half of that length. Half of that length would be what? 9 over 10? So positive and negative 9 over 10. So that's endpoints of the lattice rectum. I think the last thing is we need to discuss is the eccentricity, and that's C over A. Let's see. C over A would be square root of 34 over 2 divided by A, which is 5 over 2. Actually, those 2's cancel and we get the square root of 34 over 5. Or if you want to grab a decimal, that's about 1.2. My goodness, that was a good one, wasn't it? Wow, that was fun there. There's a sketch and discuss for that problem. The numbers weren't quite integers like we're used to seeing, but I want to show you we could do one. We're tougher now. We're building our mathematical muscles on this. Okay, the next thing we're going to do is I'm going to give you some information and we're going to write the equation like this in standard form for the hyperbola. Let's do it. So write the equation or find the equation of the hyperbola. They tell us it's a hyperbola. So we know the form of it. Okay. First problem, they tell us that a focus is at 4, 0 and the vertices at negative 2, 0. All right, picture this. Focus is at 4, 0. Vertex is at negative 2, 0. Now, automatically on this, it tells us two things. What does it tell us? This tells us that C is 4 because the distance from the vertex to the focus is C. Now this, the distance from the length from the origin to, or the center to the vertex is A. So we know A is 2. So we've got A and C. And guess what? We can find C squared is equal to A squared plus B squared with the hyperbola. So let's see. C squared would be 16 equals A squared is 4 plus B squared. We don't know B, so we subtract the 4. It looks like 12 is equal to B squared, and we can stop there. Now we need to decide where's the major axis? Where's the major axis? It's going to be the x-axis because that's where the vertex and the focus are. So the major axis is the x-axis. So we are looking for an equation that's x squared over a squared minus y squared over b squared equals 1. And we know a and b. So we've got x squared over a squared, that'd be 4, minus y squared over b squared. Well, b squared is 12. We already have b squared is 12 equals 1. This is a great example to show you that A is 2 here, and B is the square root of 12, that A is not necessarily bigger than B in the hyperbola. So that is a great example to show you that. Let me do one last example, make sure we got this. You guys try this one on your own. How about if I tell you the focus is 0, 10, and the eccentricity is 5 over 2. Could you write the equation of the hyperbola knowing those things? I want you to stop the video right now, pause it, and then you can come back to it. I want you to see if you can do this one on your own. Okay, hopefully you're back with me. You said, oh, guess what? This tells me the C must be 10. So 0, 10 is right here. The focus is 0, 10. It also tells me the major axis is on the y-axis because of that 0 and 10. So I know it's going to be a y squared over a squared plus an x squared. Oh, no, no plus. No, we're with hyperbolas. Minus an x squared over b squared equals 1. Sometimes my head and my hand starts going and my head won't catch up with it. All right, so we already know C, but we need to figure out A and B. So let's see, we know the eccentricity is 5 over 2, and 5 over 2 is the ratio of C to A, because that's what eccentricity is, and we know C is 10. So I know 5 over 2 equals the C I know is 10. That doesn't mean that C is 5 and A is 2. That just means the ratio is 5 to 2. In our case, C is 10. So guess what A is? When you cross multiply, 5A is 20. So A must be 4. So that'll be a ratio of 5 to 2. So we know A is 4. So we know it's a y squared over 4 squared is 16 minus x squared. We just got to find B. Let's see. We know A and we know C. We know that C squared is equal to A squared plus B squared. Let's plug these in. What's that? 100 is equal to 16 plus B squared. It looks like B squared is equal to, subtract the 16. We get 84. I can stop there because B squared is 84. It's just much easier just to go backwards like that. There's the equation of the hyperbola. Whew, we've done a lot of stuff. Okay, so our assignment is going to be on 5.4. It's in your textbook. We're going to do number 1, 3, 9, 11, 13, and 15 through 21, the odd. We're going to try those problems out. If you have any questions, you know where I am. Come see me during our instructional support period, ISP. Come see me, send me a message. We can Zoom tutorials, send me an email, a Remind 101 message. I'd love to help you. Hope you had some fun with these hyperbolas, and that finishes our chapter 5, where everything is centered at the origin 0, 0. Chapter 6, we're going to start sliding it, rotating it off of the origin, and we're going to have some fun with those. You guys have a great day. Get a hold of me if you need some tutorials. We'll catch you later. Bye-bye.